Today we are starting from question number 2. This is the question: if A is equal to 1, 2, B is equal to 2 and C is equal to 5, 6, then verify that A cross B intersection C is equal to A cross B intersection A cross C. Let us see solution. A cross B intersection C is equal to, we can write again A cross B and C. See the two element, and here 5 and 6, no common element, so it will be the null set phi and equal to phi. Since A has some elements but there is no element in phi set, ultimately cross product we have seen in the last day in remarks that if one of the set is null set, then the total cross product is phi null set. Okay, again this side we shall verify now. A cross B intersection A cross C equal to A cross B C. Take the set, first element 1, 2, second element 2, 2, okay, and then intersection of set A cross C. A is 1, 2 and C is 5, 6. So 1 will come to 5 and 1 will go to 6. Again 2 will go to 5 and 2 will go to 6. So we write it 1, 5, 6. Now compare between this set and that set. No ordered pair is common. 1, 2, no. 2, 2, we do not find anything. So this is again equal to phi set. Okay, it's very wide. That means both right side and left side becomes null set. So this is very wide. Next is question 3. If R is the set of all real numbers, then what do R cross R and R cross R cross R represent? Remember that you have learnt in Cartesian coordinates x, y. If this is a point x, y variable, we have seen that x can denote any real number along the x-axis and y can denote any real number along the y-axis. These are the set of real numbers we have studied. Okay. Similarly, if z-axis is here, then x, y, z will be added another one in space. Okay, x, y, z, all are real numbers we have studied. So briefly we can answer. R cross R represents the coordinates of all the points in two-dimensional space, while R cross R represents the coordinates of all the points in three-dimensional space. Okay, this is the answer. Question number 9. See the things here. Elements in set A is equal to 3 and in set B is equal to 2. And again it is given that x1, y2 and z1 are in A cross B. Find the set A and B where x, y and z are distinct elements. See the solution. Given number of A is equal to 3 and number of elements in B is equal to 2. And these are belonging to A cross B, whereas these are x, y and z are distinct from. Therefore A is equal to x, y, z. B is equal to 1, 2 comma 1, but one repeated elements can be omitted in a set, you know, from the knowledge of first chapters. So you write is equal to 1 comma 2. These are the things. A is equal to this and B is equal to 1 comma. Next question 10 from exercise 2.1. Cartesian product A cross A has 9 elements, it is given, and among which are found -1, 0 and 0, 1. Find the set A and remaining elements of solution. Number of elements in A cross A is equal to 9, equal to number of elements in A into number of elements in A, implies number of elements in A is equal to how many? 3. Also given -1, 0, comma 0, 1 belongs to set A cross A, implies that elements -1, 0 belongs to A and element 0 and 1 belongs to A, implies -1, 0 and 1 belongs to A, we can say by combining that one. Therefore, A is equal to 1 comma 0 one time and 1. Okay, so we have found the set A. Since 3 elements are there and these are the elements. Okay, 0 is repeated, so we are omitting, taking 1, 0. Okay. Now we shall find the remaining elements. Remaining elements of A cross A is equal to -1, 0, 1 cross -1, 0, 1 are -1, -1, first element, second element -1, 0, but -1, 0 has been given, so you don't write. Then -1, 1, -1, 1 you can write. Again 0, first element, 0, -1, 0, 0, then 0, 1. 0, 1 was given, so leave it. Then come to 1, 1 minus 1, minus 1. Then 1, 0. 1, 0 was not given. 1, 0. And then 1, 1. So you are getting 1, 2, 3, 4, 5, 6, 7. These are the remaining elements. Now we shall define the relation. What is the relation actually? This is the definition. Any subset that belongs to A cross B is said to be a relation from set A to set B. Okay, this is the thing. Since the video is going to be longer, I am getting a stop here today without taking the important remarks on relation that I thought to cover today itself. Next day I will present a list of printed remarks on relations